All righty. What will come of this? Is it over already? Oh. That was a bit of a letdown, I gotta say. I was expecting much more out of that. David, all the way through class and no swearing. Well done, look at you. It's 10:03. Anybody in David's science class, you would get that joke. But if you're not, it's not going to mean anything to you. I must say, David, I was pretty shocked by that. You're a pretty respectful, quiet fella in here. What are you trying to do to poor Miss Purvis? Okay. Just checking. Everything we are going to do today, I lie. I'm the worst kind of liar. 90% of what we are going to do today, you did in the 9th grade. It's possible that you did everything we did today in the 9th grade, depending on who your math teacher was. Okay? Sorry. No, that was the right one. Depending on who your math teacher was, it's possible you've done everything we're going to do today. But you may not have. Either way, it's no problem. We're going to be going over it. So, let us begin with powers are used to express repeated multiplication. Please underline, thank you. The screen is not on. Please underline, highlight, draw a Mrs. Bad Crumble cloud around it. I don't care what you do, but somehow remind yourself that it is repeated multiplication. This is not 7 times 3 to get 21. You all know that already. But I guarantee you, at some point in this unit, one of you is going to do that and yell the answer out loud. I'm going to say, what is that? And somebody in the class is going to say 12. It's okay. I don't mind. I know it's 36. But somebody in the class is going to say 12. And that's okay. This is really 7 times 7 times 7, which is really 343. Now, before I go any further, we're going to do something now just to make sure everybody can do it. I already know that all of you know how to use your calculator to square stuff because we did Pythagoras. I want to make sure that everybody can make their calculator do exponents. Even though in grade 10, we don't do this a lot. So everybody on their calculator needs to know how to do that to get 343. Your calculator is probably different from your neighbor's. But please make sure you can do it. If you don't have a calculator, it's no big deal because, like I say, very rarely in the 10th grade do we ever calculate this. Ms. Glenn, what can I do for you?
Making a personal visit for 2 kids for course planning. Oh, no.
Key. Who?
Olivia Clausen and May Hugh Lee.
Olivia? May we? With that lady.
Bring pens.
Bring pens.
Thank you for letting me interrupt.
I will record this. You will miss nothing. Everybody can do it, right?
Thanks, Matt. Pardon? Yeah.
Okay. Remember, it depends on your calculator. Some of you need this button, X with a Y. Some of you need Y with an X. Some of you need this little button that looks like a mountain. It's called a carrot. It's not spelt the same as the vegetable. Some of you, no, it's not the same as the diamonds either. It's C-A-R-E-T. I know, right? Crazy. Some new calculators recognize that we are getting so bad at math that they actually draw a picture of X with a blank instead of X to the Y. Yeah, I know. It's appalling to math teachers. Yeah. No, that's X squared, dude. That's not what you need. That only works if it's squared. All right. Okay. So everyone can do it. Yeah? Yes, Heather.
I actually have a button that's X cubed.
X cubed as well? Well, lucky you. Not all calculators will have that.
If I need to do something that's bigger than a cube.
Then you need to use one of these buttons, whichever one you have.
Like an X and a 1 over y?
Nope.
Is it E
Nope.
and X?
No, it is one of these 4 buttons, Heather. It is X with a Y, Y with an X, a little caret sign, or X to a blank. This, like a little mountain. It's okay. We're very rarely going to use it in Math 10. I'll help you in a sec. All right, so I'm going to do some highlighting here. You guys can highlight. You can do what you want. Like I say, most of you already know this stuff. I'm going to highlight the base. Who would like to tell me what the base is? It is the 7, indeed. The 7 is the base. In the 9th grade, you did a ton of this with numbers, right? Okay. The base is the math, there's no E on the end of math. The math expression that is multiplied. That's what the base is. So this means 7 times 7 times 7. Okay? That's easy. Everybody gets that. That's no problem. In the 9th grade, you did work with this as numbers. You may not have done this. A cubed. What does that mean? That means A times A times A. Okay? Some of you will have done some exponents with a variable base, and some of you may not have. So I'm going to assume that nobody has. The reason I'm assuming that is because everybody says this unit, oh, thank goodness, we're doing easy stuff. Believe it or not, this test is always the worst test by the end of the year. Always. I don't know why. Everybody says they get it. Everybody says, oh, it's easy stuff. We're back to the easy stuff. And yet. So please be careful with this, okay? It's not necessarily as easy as you think it is. All right? So everyone's cool with that? The base, the math expression that is multiplied. That's what the base is. Now, in a different color, I'm going to remind you of something. It's what is directly. And please underline, or make a cloud around it, highlight it. I don't care. That word, directly left of an exponent. Now, I know you're not supposed to use the definition of a word you've got to define, but I'm doing it on purpose because you read this in order. The next thing you would read would be exponent. And what would the exponent be here? That's the 3. Now, the exponent is the number of repeated multiplications. And that, and I'm going to use the real word for it, it's the superscript. Now, superscript does not mean it jumps into a telephone booth and takes off its clothes and becomes a superhero. Superscript means it's above the line. Those of you in Science 10 right now are aware that you also use subscripts in chemistry, and they are below the line. All right. Everybody cool? And, of course, the power is... Oops. Holy crap, that was fast.
Yeah.
Well done. Why did it take 40 minutes for it? Never mind. The power is both an exponent and a base. Both of them together make the power. The power here is 7 to the 3rd. The power is not 3. The exponent is 3. I know that seems fussy, but it matters. because as math gets more complicated, you need to be aware of that. And as math gets more complicated, you are going to find out that your bases are not necessarily one thing. Everybody good? All right. And this, of course, we read all of these as the base, whatever the base is, and then we say to the exponent power. So this is 7 to the third. If it was a 4, it would be 7 to the 4th, 5th, 6th, and so on. Now, you are all aware that anything to the second power is squared, and anything to the third power is cubed. Nobody else gets a special name. I hop back and forth between those all the time. Sometimes I'll say 7 to the third, sometimes I'll say 7 cubed. Everybody cool? All right. Now, this whole table is all stuff that you should have seen in the 9th grade, except possibly this row. But by then, you should have figured it out. All right? Now, fill this in to the best of your ability. There are some tricks on here that are designed to fool you. So don't use up all the space if you can avoid it, if you're working in pen. If you're working in pencil, be ready to erase in case you make an error. Everybody good? Try to fill that in. I will remind you that evaluate means give me a number with no exponents. So that very first example, 7 to the third, evaluated, it's 343. Everybody cool? Fill this in. It should take not very long because you already know how to do it. And I'll be right back. I am going to, as always, be talking a little bit about a couple of them. Make sure you did it okay, because like I say, this is all the stuff you should have seen in the 9th grade. I have certain spots where I find that there is often mistakes. The first one is the very second line there, because a great many of you forget that the exponent is directly to the right of a base, and the base is directly to the left of an exponent. So when you see this one right here, some of you tell me that the base is -3. It is not. The base is 3, because 3 is what is directly left of the exponent. So this, the base, is what multiplies 3 times. 3 times 3 times 3 is 27, but that whole thing is negative. So this becomes negative 3 times 3 times 3, 27, which we write as -27. That's why the next thing has brackets. The next one you can see has brackets. What is the purpose of brackets in math class? What do they do? Group stuff together. So because this bracket is here and this bracket is here, everything inside those brackets is grouped as a single unit. So that's why this is a negative base. So since the negative is part of the base, the negative also repeats. So negative times a negative gets me a positive. Everybody cool? Nathan. Well, if it's further down, why don't we wait till we get there? Excuse me, coffee, wrong pipe. Why are you laughing at me? It hurts. Ooh, it's not like I'm vaping and sucking down water. What? Okay.
Why couldn't you just put -3 times -3?
Because the negative isn't part of the base there. It will give you the same answer, but they are different calculations.
Okay.
Okay. Now, the next one I wish to talk about is this line right here. Because negative 1 times 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 negative 1 got me negative 1. So if everybody understands that line, then you all should be able to tell me what that answer is. That's no. That's positive 1. Okay. Do you understand the green line, Olivia? So you understand that because that negative 1, that negative repeats every time, it's part of the base. So you understand the bracket situation. Right. So if it was to the 8th, there would be one more negative 1 there, wouldn't there? So negative 1 times negative 1 would get me positive 1. If you have an even numbered exponent and your base is negative, your answer will always be what? Positive. Positive. Okay? What if I had this? What's that one? Negative 1. Why? Why is this one negative 1 and this one positive 1? Because that negative is not part of the base. So the negative didn't repeat. Doesn't matter what is happening here, it's always going to be negative. Everybody cool? All right. That is where there's a lot of mistakes in exponent work. And then everybody should be good. This is the line that some of you may not have seen in the 9th grade. You may not have done any variable bases. But if you understand it with numbers, you understand it with letters. You can't evaluate it because I haven't told you how much X is worth. So that's why this is the evaluation of it. Everybody cool? All right. Again, this next line is what we were just talking about. To get a negative value here, I have to have a negative out in front that can't be part of the base. Everybody cool? I also could have done this. Except there's a problem with that. Some kids say, well, I just put brackets there. Why is that not okay? Because I tell you right here that the base has to be 2. Once I put brackets there, what's the base? Negative 2. Everybody cool with that? That's why this one is written that way. Everyone is good? Okay. Now this one, there's 2 ways to have 3, because this was all blank. There's 2 ways to get to positive 9. I could have 3 squared, 3 times 3. Or I could have negative 3 squared. Negative 3 squared, negative 3 times negative 3 will get me positive 9. They both work, right? And then down here, I went the other way you could get 9 with an exponent is just 9 with an exponent of 1. So 9 doesn't repeat at all, so it's just 9. And then this one causes problems all over the place. Because, okay, everybody is usually good. All right, the base is in brackets, so it's negative. Got it. Exponent's positive, or 6, even, got it. So 6 times 6, oh, there's only 4 of them there. 1, 2, 3, 4, 5. 6 negatives would give me a positive number, wouldn't it? But at the end of it all, it's negative. So that negative has to come back at the end. Everybody cool? Because the base was negative 4. The brackets are around each one to show that the base also repeats. Everybody good? That's all of grade 9 on one page for exponents. Is everybody good? Everyone's solid. Okay. So now, turn the page over, page 79. You are going to be good until number 7. You already know everything on these pages until number 7. But we're going to go over them because, like I say, when we put them all together, this ends up being a difficult unit for students. All right? So, you already know this. So, multiplying powers with the same base. In the 9th grade, you did this. 2 cubed times 2 squared. And what's the answer? 2 to the 5th, right? Right away, everyone's like, I got it. It's easy. I add them, right? Okay. Here's what I want to make sure we doubly and triply and quadruply check. Why is it 2 to the 5th? Now, all of you are going to say, because you add 3 plus 2. That isn't why. That is what you do. Why is it 2 to the 5th? Rylan. The bases are the same. So I add the exponents. Again, that's what I do. If the bases are different, you're screwed. You have to evaluate. Yeah, you can find a common base, but that doesn't always happen either. What do you got? Because they're being multiplied, this is 2 times 2 times 2, correct? What's that? 2 times 2. And they are being multiplied together. And you see that I end up with 2 to the 5th. That is why it works. Now, what do you do? If I have x to the x to the a base of x to any exponent, times that same base to another exponent, the answer is x a plus b. Everybody good? Now, Nathan, I saw your hand up behind Ryland's head. It looked weird. It looked like it was growing out of his head from where I was sitting. What? Okay. Everyone's cool, right? Now, if it happens once in math, how often does it happen? Always. So what if I gave you this? B to the z times b to the m. What would the answer be? B to the z plus m. If I gave you q to the 3 times q to the 7, what is the answer? Q to the 10th. Everyone's cool, right? All right. Next one. Dividing powers of the same base. So I'll start with, just like I had up there, 2 to the 3rd divided by 2 squared. What's the answer? 2 to the 1. Why? You subtract. Again, Helia, that's what we do. Why does it work? Nathan. What is that really? 2 times 2 times 2. What is that really? 2 times 2. What does 2 over 2 equal? 1. They cancel out. What does 2 over 2 equal? 1. What is 1 times 1? And what is 1 times 2? 2. So the answer is 2. That's why it works. Why am I stressing why it works? Because in the 9th grade, you did one thing with one exponent question. Right? In the 10th grade, you're going to use all 7 of the exponent laws in one question. So you have to know what is actually happening, not just what I do. Okay? And the shortcut over here is, of course, if I have x to the a divided by x to the b, that's the same as x to the a over x to the b, and that is x to the a minus b. Everyone is good, right? Right? Okay. Raising an exponent to an exponent. 2 cubed squared. What's the answer? 2 to the 6th. I know that you all already know I always multiply. Great. Why? What is that really? 2 times 2 times 2. What is the base here? No. 2 is the base inside these brackets. What is the base to this whole thing? 2 cubed. And what is happening to 2 cubed? It's being repeated how many times? Twice. There it is once. There it is again. So it is 2 to the 6th. And the shortcut is x to the a to the b is x to the a times b. Oops, that should be red to keep my color scheme alive. Oh well, everyone's cool. Right? Here is where the first screw up happens. Always. If you understand this, then you all should be able to do this. What is x, y? No, you know what? I'm going to wait and come back to it later. Yeah, there's a reason. An exponent of 0. 2 to the 0. What is it? No. It is 1. A lot of people don't know why. A lot of people remember your grade 9 teacher saying anything to the 0 power is 1. How many people remember hearing that? Lovely. Did anybody see why? Of course. Oh, may we? Of course you did. You saw why in grade 3. Yes, please do. Yep. So if I have x, I'm using x, so x to the a. To the a. This equals 1 because it's the same thing on the top and bottom, right? But according to law 2, this is also x to the a divided by x to the a, right? And what am I supposed to do with my exponents when I divide? Subtract. So that's x to the a minus a, right? What's a minus a? X to the 0. So if this equals x to the 0 and it equals 1, then x to the 0 must also equal 1. Does everybody understand why it works? Now, just like all math, can I forget the other math that I already know? No. So there's a lot of white space here. Why? Why do I leave that much white space? To practice the weird stuff, yes? So all of you are cool with this. 7,784 to the 0. What's that? 1. Great. What is 20 million to the 0? 1. Good. Okay. What is negative 7,784 to the 0? What is it, Tushar? It's negative 1. Why? Because it starts negative and that negative isn't part of the base. So what is this? Positive 1. Because any base to the 0 is 1. So this really is negative 1, because the base to the 0 is 1, and the negative 1 we write as negative 1. Everybody cool? Yeah? Okay. We still aren't seeing anything new yet. This might be new. And this I can't show you with numbers. I have to use variables. X, Y to the A. I know there's an M there, but I like using A's. What's the base here? X, Y. Everyone agrees? Okay. X, Y. I'm actually going to make that a 2. How many times does that base repeat? Twice. There it is once. There it is again. Right? So what's that really? That's really x times x and y times y, right? Which is x squared, y squared. Yes.
Oh, I remember when you were combining.
Everybody cool here? This, you'll notice, has a lot of white space under it, doesn't it? Which means I know that this is something kids screw up. But all of you are looking at this right now and saying, Mr. Myers, how could I possibly screw this up? Pardon? Don't give me away yet, Sage. How could I screw this up? Here's where you will make mistakes because you will forget previous laws. What would this be? X to the 4th y squared. Because you have to remember that 2 going over a bracket, like in law 3, is multiply. You can't forget that one. Everybody cool?
But isn't it brackets always first?
No, Nathan, because the brackets, what could you do inside there? Right? Okay. Everybody's cool with that one? That's the first mistake kids make. They forget previous laws. Everyone's good? Okay. The next mistake that kids make with this is this one. What is 2xy squared? It is 4x squared y squared. Why? Rylan. The 2 hits everything inside the base. So it becomes 2 squared, x squared, y squared. And 2 squared we would never leave because our goal in math is to have our final answer look as simple as possible, correct? And 2 with an exponent isn't as simple as we could write it. It's simpler to write 4. Everybody good? Yeah? Okay, so then what would negative 3x squared y cubed all squared be? There it is. The first person to do what I said would happen. What did you do with 3 and 2? Multiply them to get 6. What is it really, Sage? What is 3 squared? 9. There you go. 9x what? It's okay, man. That's why we're practicing. 9x what? 9x 4y 6. Everybody cool? Now, did Sage really not know that 3 squared was 9? Of course he knew that 3 squared was 9. Of course he knew that. How do you make the mistake? When you pile up 3 or 4 or 5 things in one question, it can happen. Which is why you got to be careful with especially exponents, because they get tricky. And we're not even at the last 2. Nathan.
Did you do it like with the exponents? It's like the negative, it's negative to like a part of the question.
Yes, the negative is part of the base.
Okay, so it's like the other questions, like the negative, the top one, like negative 774, top right now.
Uh-huh.
Because you do like another step. There's like another.
If it comes to you, put a pin in it, bring it back to me. All right. Now, what if this same question changed to this? Now what's the answer? Negative 9x 4y6. Is everybody cool with this page? Now, the whole point of this is if you're doing something with law 5, you have to remember laws 1, 2, 3, and 4 still apply. Is everybody good? All right. Let's move on to number 6. Number 6 might be something new to people. X over y to the a. You're intelligent young people. What is the base here? X over y, right? And that base is to the a. Damn it, I did it again. I did the same thing. I want that squared. What does that 2 mean for the base? It means there's going to be how many bases? 2. So it's going to be x over y times x over y, correct? Which is x squared over y squared. Exactly like multiply. The exponent goes everywhere inside the base. Is everybody cool? Now, this is law 6. Can I forget law 1, 2, 3, 4, 5? No. So what if I had 3x squared over 4y cubed squared? I would have 9 x to the 4th 16y 6th. Is everybody cool? Please notice that every law just piles on to the previous one. Basically, if you understand the very first one, which is XA times XB, if you recognize that's adding, everything else comes from that, doesn't it? Right? Everybody is good to law 6, yes? Okay. Now, a negative exponent. Please notice I've given like half the page to this. How many of you saw negative exponents in the 9th grade? Oh, good. Excellent. That makes me happy. A bunch of you. Not all of you, though. So we're going to take a moment with this. A negative exponent would be something like 3 to the negative 2. Knowing what we know now, what's the base there? 3. And what's the exponent? Negative 2, which means I should take 3 and I should multiply it by itself negative 2 times, correct? So if I was going to draw it out, don't draw this. That's great drawing, idiot. There's 3, right? Right? Now if I'm going to use a drawing to illustrate exponents, I must do 3 how many times? No. Forget the negative. I have to make a square of 3's, right? So 3, 3, 3, and I get 9, right? Makes sense. I made a square that was 3 squared. Everybody cool? So how could I make that 3 repeat itself twice negatively? Now, those of you who have seen negative exponents already know the answer to this. But if you haven't seen a negative exponent, can you think of a way to draw this? It makes no sense, does it? You can't multiply something by negatives because negatives aren't really there. Is everybody with me? Okay, so this makes no sense. So it's not allowed. Never can you have a negative exponent. Ever. Now, some of you already know that what this answer is. Some of you already know that. Please don't yell it out because I want to show everybody what it is. Okay? What is 2 cubed? Really? It's really 2 times 2 times 2, correct? And what is its value? Really? 8. Cool. All right. What is 2 squared? Really? 2 times 2, and its value is 4. What's the relationship between 8 and 4? Half, which means I've divided by 2, right? And that makes sense. I took 1 2 out of this multiply, which is division. Everybody cool? What's 2 to the 1? Really? 2. And what's its value? 2. I divided by 2 again. Everyone still cool? And then what's 2 to the 0? 1. Right? And 2 divided by 2 is 2 over 2, which is 1. Is everybody cool to there? Now, you're intelligent young people. Even if you haven't seen negative exponents, what would be the next logical exponent in this line? 3, 2, 1, 0. Negative 1. Now, this, we know, makes no sense, correct? But if something happens in math, what's happening? It keeps going, right? I keep dividing by 2, yeah? What is 1 divided by 2? Don't say decimals. We're in the 10th grade. We don't use decimals anymore. 1/2. So what then, logically, is 2 to the negative 2? 1 over 4. What then is 2 to the negative 3? 1 over 8. Everyone see the pattern? 2 cubed got me 8, which is really 8 over 1, isn't it? 2 to the negative 3 got me 1 over 8. What happened to this fraction? It flipped. Does anybody remember the proper math term for flipping a fraction? It's the reciprocal. Is everybody cool? So, the rule is x to the negative a is the same as 1 over x to the positive a. The exponent stays the same, but it becomes positive. Is everybody good? No, do not say that. And I'm about to show you why. Does everybody understand this? Okay then. What then, if you understand that, is 1 over x to the negative a? What part of that isn't allowed? The negative exponent. Negative exponents create what kind of fraction? No. Sage already said it. What does a negative exponent reciprocates a fraction, right? So do I have a negative exponent here? So what must I do to that fraction? Reciprocate it. So what will this become? It will become x, not negative a, because when we reciprocate, what happens to the exponent? What happened here? Became positive. So what's going to happen here? And it's going to be over what? 1. Now, do we ever write anything over 1? No. So it becomes x to the positive a. Is everybody cool? Great. So now let's see if you really are. What is x over y to the negative 2? It is y squared over x squared. Why, Rylan? Because it seemed like the right thing to guess. There's a reason I stopped there. The work is hard. That's where we stop. We have work tomorrow. I lie. We have work Wednesday because we're testing tomorrow.